Hello everyone, welcome back to another video. It has actually been exactly 4 months to the day since I've made my last content, partially due to an internship and just classes getting back. I am now a sophomore. And what I wanted to look at was something called observational forecasts. So a big reason for why I haven't really had many videos out is because I am currently taking a class at university, which is all about forecasting with observations only. If you ever watch my videos, you'll see that I use weather models a lot. I am often on this page looking through how a severe weather day might go with a RAP run or a NAM run. I might compare to the GFS or the Euro and see how they all line up over time. And that's something that I have been not doing for the past basically 2 months now. We're only doing forecast observations, and I kind of wanted to show a little bit of how that works and kind of the difficulty behind it. I'm just kind of thought it's a really interesting thing. We'll segue back into some more content because I do want to make some more videos now. Just because I didn't realize it's been so long. But yeah, I'd like to look at some of these different pages more on observations rather than modeling because that is something I often do, and it's honestly just interesting to share. Not looking at this and how you can see similar things in other features. So one page I can look at, this is going to be also College Do page because they have basically everything you could want for weather. I can look at basically the exact same thing I'll see in a model, but observations only. So notice here the 12-hour increments on this map. This is your 250 millibar map. This is your upper level winds, upper level geopotential heights, which is basically just pressure, or similar to pressure. It does correlate. And you can see basically our pattern. We see our trough here, ridge here. Basically the same thing we look at anytime we make a video. But notice how you only have 12-hour increments here, and that's because every 12 hours at 0 UTC and 12 UTC, which in Central Time is usually around 7 a.m. and 7 p.m., 12 hours, 12 hours between each balloon launch, you will get observations in the sky from radio sound observations. That's your weather balloons, basically. That'd be a whole other topic, whole other video if I really wanted to, because I mean you could even see them getting launched if I really wanted to. But the idea is you only get observations every 12 hours, and that really is a large time gap to have to work with. Here's Wednesday at 0Z. Here's Wednesday morning, about 48 hours ago. At that time, we had this large scale ridge over the southeast. We had this troughing going on, but with only this information, it's hard to tell where your trough is going to be moving, if it'll be weakening or strengthening, and that's a huge disability that you end up with these observations, right? You're only getting observations every 12 hours. If we look at our models, I am getting an idea of the atmosphere every hour as I go on with time. This is at 1 p.m. Central Time. This is at 2, 3, 4. Basically, every single frame here is a single hour. Compared to this, these observations, every 12. That's a huge disadvantage. But also, to be fair, you can't trust a model run. This is not going to be accurate information. It might be very close to accurate, but this is not 100% accurate. Observations you get, that is the observations. That's what we found. That's what the atmosphere is doing. It's a big difference, and it's kind of interesting to see how that changes. I can go down to 500 millibars. Same thing, right? We used to have that really strong jet streak that I saw at 250 millibars up here. Compare there. Here's a 250 millibars, and that stronger wind way back in there. 500 millibars, it's similar but different, right? Compare the two levels. A lot stronger going on out here at 500 millibars compared to 250. But again, we still have to base off what we had in the past. We go forward with time here every 12 hours. Notice how quickly that trough deepens, right? We have this little pressure system kind of going on right around here. I wouldn't trust this low point as much because based on the winds, it's more centered here. It's a very quick strengthening, and then it cools off to the northeast. It's really interesting just to see how observations compare. And a big part of observations, honestly, is satellite. This is something I've been trying to look at more on this channel. I do a few videos on satellite imagery, true color, especially the true color ones. I remember last year we did have some dust storms go on in Illinois, actually, which was really surprising, as well as a lot of smoke at some points from wildfires up in Canada. And here we can see a satellite imagery. This is from mid-level water vapor. What's really interesting about this is you can work on picking out some features as we move on with time. So pay attention here to about Montana, near the Dakotas here. You see this swirling little vortex there, and that's one of our troughs. That's that same trough that we saw on the observation side here, at 500, so excuse me, 250, 500 millibars, all that here. You can see there's that little shortwave trough there. We go back to satellite imagery here. Again, we play this loop again. You can see exactly where that shortwave is moving up through here. It's a little harder to see the main flow actually as well here, just because it's much more confined up here in Canada. That's where we get our geostationary satellites from NOAA. That's where we can change our sectors. That's what things get really interesting. So let's switch to this west sector here. I'm going to take a sector over the Pacific Ocean. This might be something I've never really showed on this channel before, is this whole view, right? You can see a lot more. You can see all these troughs out here. Here's one near Hawaii. You have this low pressure cyclonic rotation there. That's the satellite loads here. You can see that shortwave here, another shortwave up here, kind of a larger scale troughing feature right here, especially right here, pretty even kind of pretty deep trough out there as well, right? You can pick out some features, especially when you do get that difference between where you have moisture and where you don't have moisture. That's kind of what's being shown here again. Don't forget this is mid-level water vapor. That's that moisture that you're seeing. Obviously, some things get distorted up here as you get closer to the poles. The best imagery is probably in this general vicinity in the Eastern Pacific out here. Really, you can see a lot of things with satellite. That's what makes this really interesting, right? With your model runs, we don't really get a good picture of what might be going on over here in the Pacific, really. I mean, you don't, with the wrap run alone, you only see this strong flow, and you don't really know what's going to go on with it. You'd have to go out a little bit better to maybe a GFS run to get a bigger picture, right? You have this large zonal flow, and then you get this shortwave feature coming up from up here. You might not get that picture from a wrap run or even a NAM run sometimes. These are supposed to be North American models, but again, rapid refresh model, that is more for specifically the CONUS, specifically the United States. The NAM run is North America as a whole, but again, if I want to know what's happening in, I don't know, maybe near the Asian Pacific area, right? Off the coast of Japan, what's going to be coming to the Aleutian Islands? I'm forecasting for Alaska, we'll say. Then you don't really know what's going to happen with that model run. You'd have to go for a more global run, find a different model, and that's where that observations really comes in. So I wanted to kind of show this, again, just all these different satellite loops. I'd like to get a little more into this because satellite is really interesting is what I've been learning, right? I made this channel back in my senior year of high school, and at that time I basically had some knowledge of how model runs work with severe weather, but nothing besides that. I'd like to look a little more at the satellite as we go on with time. Infrared satellite, how that's important. Basically, infrared being the temperature that the satellite is seeing. So these are a little bit colder out here, especially these really deep black colors. Those are those really deep convective thunderstorms, right? You're seeing out here in kind of the Caribbean. Although, let's see if this loop will go. Seeing the Caribbean, all these thunderstorms going on, kind of near Central America, the Eastern Pacific, kind of just general region. That's often a way we can look at tropical developments as well. Maybe we'll even see it over the North America as well, right? You do see some of those colder colors, albeit not nearly as deep as some of this convection going on more near the tropics, but you do get that convection from a few storms. That's because those clouds are getting really deep in the atmosphere, getting really cold. We can see some cloud cover over here in the Eastern Pacific here. Really, a little tricky to see, but you can see just based on the temperature difference, right? If I change to visible imagery, I can see what our visible channel looks like. There's all those same clouds. We'll compare this, right? Here's 20Z, 20 UTC, and then I'll compare that to the infrared imagery at 20 UTC. We'll let this load. It does take just a moment. But again, you can still see a lot of that cloud cover, and that's how you can really combine some things together. So here's the same 20 UTC compared to that visible we just saw a second ago. You do still have that cloud cover going on out there. That's where you can really just begin to pick things apart. You can see that cyclone out here, kind of near the western Aleutian Islands going on right there. But really just very interesting to work with the observations. Other things I also want to look at were surface observations. Now this will be a little bit of a scattered, a little difficult of a website to look at. This is the Aviation Weather Center. This has live radar imagery, as well as kind of flight rules and stuff. Something I have not learned enough about, and I would like to know more about. But again, that's kind of why I'm at college. I have looked at surface station plots before. You can see the surface, observations at any point here, right? I can go down to Texas here if I want to look at where I'm flying my planes. Really just anything here. We have gusty winds over this region of Texas, right? Gusting up to 24. all based on METAR observations, which are something that you get from something called an ASOS station. It's kind of complicated, but basically you have lots of weather observation stations across the country. I believe most of the ones we see on these page are commissioned by the TAA, or I believe it's the TAA. I forget what the FAA, sorry, the Federal Aviation Administration, I think it is. They administer a lot of these stations, which is unique that we get so many observations like this. But for like over this region of Texas, I can see a little bit of convection out here, right? It's a convective warning, a big reason why you might not be able to fly through that one zone while you're coming home. I remember this summer in July, I was taking a flight from Tampa to Midway, and we had a lot of convection here, right? We'd get a convective warning basically all along the state of Indiana. I'm in parts of Chicago for a lot of that day. If you're curious and want to look it up, July 25th, you can look that up and see the past, convection, how that radar looked. But that actually diverted my flight all the way down here to Cincinnati, and that's where things get really interesting, right? Is how convection can affect your flights. You get turbulence around it, but really all this that you're seeing right now is observations. You have pressure, temperature, dew point, and I believe visibility here as well. 10 plus statute miles. So you can see a lot that helps with cloud cover, right? I think we've looked at stuff like that on this channel a little bit as well before. Up here in actually Valparaiso, I'm looking outside right now. It's where I'm at campus, and it's cloudy. It is overcast for the most part. We're starting to see some breaks in the clouds now, but it is still pretty cloudy. That's so you can see that full circle there, right? That full green circle. Then here you're seeing a METAR observation. Again, this is complicated. You look at this and you think, what is this gibberish I'm looking at right now? METAR, KVPZ, a bunch of numbers, auto. And there's a way you can read these. That's something I'll also learn about. I won't look at that too much on this channel, just because it's a little more complicated, a little more into the instrumentation side of things. But it's kind of an interesting look at how you can compare like the modeling world to observations themselves. Because observations, you only get so much information, and you have to infer a lot about what is going to happen with time, right? I can take my satellite loop here. I'll take upper level water vapor so I can try to get an idea of what our upper levels look like. What I'll see out here is this really strong jet stream right there, kind of south of the Aleutians over the Pacific there. You can see this troughing feature, and you can watch the wind pattern here a little bit like this, right? So you can kind of infer where our general troughing is, something like this. And you do have that really strong spot with that kind of jet max right in this vicinity, right? Before the time, again, you can continue to see this deepen and take on more negative tilt here as well, right? You can see how this wind has moved with time, again, with pointing more towards the northwest as a trough axis, which is just interesting to see so far out like that. And then again, we are predicting a shortwave feature up here, kind of in Montana, to come down, right? But even then, on the satellite imagery, it's a little bit difficult to see, right? You can see a little bit of that shortwave feature right here. A little bit tricky to pick out, but you can see how we do have a little bit of, that wind movement more north or southerly right here, kind of hinting at that jet streak, as well as some very strong upper level movement right here. And those will combine into a shortwave right here later on. But it's a little bit tricky to see with just satellite imagery, and that's one of the biggest weaknesses. Again, it's just that you're getting observations only at a specific time. So if we compare back to our, GFS run, we'll go to North America, so you can see that shortwave out here develop. Very quickly, it deepens there, and this is much easier to see on modeling. So just a little bit of a combination, and something I've been learning as I'm here. It's kind of the point of this channel, is to talk about things I've been learning, things that are kind of interesting to me. And one of these is, again, just this observational versus modeling comparison, just because it's really interesting to see how going from observations only, where you only know so much at a certain time, you have to kind of infer a lot, and that can be very inaccurate at times as well, especially due to precipitation. Precipitation is a real tricky thing to forecast without any modeling, even with modeling, in all fairness. But that's a big difference, and I just want to kind of highlight it. I know this video is a little bit more technical and a little bit more, weird, but hope you enjoyed the video though. That's kind of the idea though. I just want to show some of the things I've been learning in university, and we should have more forecasting videos coming out, especially now as the pattern's getting a little bit more active for severe weather. Looks like we're kind of entering that second season, especially for the Midwest, but really just the U.S. as a whole. It's been really quiet on the SPC side as well. And something I have within this on this channel is soundings, but a lot of the time I'm actually taking soundings from models. I'm looking at forecast soundings. If I want to see what our pattern looks like right here in Minnesota, kind of near the jet streak, I can click on it on frame 11, so in 11 hours, see what the RAM model thinks will be happening, and I look at this entire profile, see how the temperature changes with height, how the dew point changes with height, and this is different as well. Whereas I will look at observations, I can look at our SCUT that this balloon sounding from Minneapolis, you can see it's a very similar thing, basically the same SCUT. But we do look at this as well. This is also observations, and yeah, another observational tool. So again, I've probably taken a little bit of time in this video, but I did want to just have something else on the channel because it has been way longer than I had anticipated for it to be. But yeah, just a little fun something. I hope you enjoyed this video, and yeah, I'll be hoping to have some more videos out. Maybe a video out for the most recent slight risk we have going on. This has been out from day 6, but I might have a video out on this at some point as well. So thank you all for watching, and I will see you all next time.